friends, we are continuing in coordinations chemistry. In last video part, coordinations part 1, we are discussing that the coordinations compounds complex and it's the complex ions. This the complex ketions, complex anion and neutral complex. Okay, this they discuss that CuNH36 and 3 plus is charged pair. This is the 3 plus is the charged pair with the detailed discussions of CuNH36 and Cl3. It's the CuNH36 and 3 plus is charged pairs plus 3Cl minus is the negative anion. Since the complex anions, it's a CO, CH3, NH3, 2 and minus 1 is the charged pairs. This is the negative, this one is the anion, show that this one is anion, this one is the anion, show that, and this one is positive terminal charge, it's the charge pair also called cation. This one is negative charges Cl minus, this also separated that positive charge ion, it's a positive anions also, sorry, positive cations also separated that, and this the one anions is also separated that. Discussion in the next type is the neutral complexes CO, Cl3, NH3 or thrice. It's also charge pair is zero, it's also called neutral complex. Coordination compound K4 FeCN6. This one is the compound and complex containing complex atoms. Next one, we are discussed the modern theory of coordinations chemistry is based largely on the work of Alfred Werner in 1866 and 1919. This not down the dating that 1866 and 1990. That's the Nobel Prize in Chemistry in 1913. This is the theory of the modern theory of the coordinations chemistry is the Alfred Werner saying that, giving that. This is the Werner proposed the putting all molecules and ion within the sphere in bracket and those free anions that dissociate from the complex ion when dissolved in water and outside the bracket. Okay, next one is the structure of complexes. The central metal ion, it is an acceptor atom containing a vacant orbital to which a fixed number of ligands are attached to via coordinate bond in definite geometrical arrangement. The molecules or ions coordinating to the metal are the ligand and they are usually anions or polar molecules. Aqua, amino and chlorido and cyano. This is the central metal ions. This is the structure of complexes. It is the acceptor atom containing vacant orbital to which a fixed number of ligands are attached via coordinate bond is defined geometrical arrangement. The molecules and ion containing two metals, that's ligands, and they are usually anions or polar molecules. Next one is the coordination pair. The central atoms and ligands comprise the inner coordination pair. The complex ion enclosed in square brackets is behave as a single unit, and ionization pair is a part of compound present outside coordination pair, and an outer coordination sphere is constitute a positive or negatively charged ion that are on more distance from the central ion or associated there with the central metal atom. This is the example of CrNH36 or Cl3. That's a coordinations number 6, and this is metal atom and this coordination pair. Calculate that the number of coordination pairs are also called the number of coordinations number, that is the number of coordinations number. And central metal atom is chromium. Chromium is also connected with the coordination pair like that. This ligands and the central metal atoms are also connected, that this called coordination pair, that. And outer side, that the chlorine atoms, that also ionization pair. Next one is ligands. It is an ion or polar molecules capable of donating a pair of electrons to the central atom via donor atom. That's types of ligands. And unident bidentate ligand, tridentate ligand, unidentate ligand. First one is unidentate, bidentate, tridentate, hexadentate ligand, chelating ligands. That is the type of ligand. Ligands with only one donor atom, example ammonia and chlorine and fluorine. It is the unidentate ligands. It's a fluorine, chlorine, and ammonia. It's a bidentate ligand with two donor atoms. Example ethylene diamine. It's a C2O42 minus oxalate ion. It's a tridentate ligand which have three donor atom per ligand. Example diethyl triamine. Diethyl triamine. Diethyl triamine. Hexadentate ligand and ligand which is a six donor atom per ligand. Example EDT ethylene diamine tetraacetate. And chelating ligands is a multidentate ligand stimulate simultaneously the coordinating to a metal ions through a more than one side is called chelating ligand, and those ligands the product a ring like structure called the chelate, and chelations increase the stability of complex, and this effect is called chelations effect. Next one is the discussions for structure. The unidentified सॉरी यूनिडेंटेट्स के उसमें H2O NH3 फ्लोरीन क्लोरीन साइनाइड आयन thiocyanate ion hydroxide ion nitrate ions also included in unidentate ligands. And we are discussing bidentate ligands in including ethylene diamine, this EN, and oxalates. It's also included that bidentate. And third one is polydentates, diethylene triamine and ethylene diamine tetraacetate EDTA. It's also polydentate ligands. Number of ligands are also connected in we are discussing in simple language. One ligands are connected to metal central metal atoms. It's called unidentate ligand, and two ligands are connected in the central metal atoms. It's called bidentate ligands. And number of ligands are number of more than one or more than two. That's it's a higher number of ligands are also connected that metal atoms. It's called polydentate ligand. We are discussing the example of polydentate ligand. First one is diethylene triamine and ethylene diamine tetraacetate EDTA, ethylene diamine tetraacetate, and it's showing the structure. That next one is coordinations number. It is the total number of ligand attached to the central metal atom through coordinate bond, or the number of atoms or ligand attached to the same central atom Example, hexadentate ligand should be count as forming six coordinate bond, charge of central atom Ag plus 1 and copper plus 2, bismuth plus 3 and zirconium plus 4. That is coordinations number 2. And the second one is coordinations number 4 or 6. Bismuth is coordinations number 6 or 4. Zirconium, it's a coordinations number 8 or 6. Next one is oxidations number. It is the charge which the central atom appear to have if all the ligands are removed along with the electron pair that are shared with the central atom, and the coordination pair that and the ionization pair. This is CrH2O4 Cl2 and NO3 and CrH2O4 Cl2 plus. And because the ligand H2 is neutral and C2Cl minus is carried two charges. Cl minus. It's a carry charges. That is the oxidations number of plus 3. We are discussing that the separating that the simply multiplications of the complex 6, knowing the charge on the complex ions and charge on each ligand, one can be determine the oxidation number for the central metal ion, or knowing the oxidation number on the metal and the charge on the ligands, one can calculate the charge on the complex ions. That's the structure of coordinations that ligands and ionization pair that discussing that ammonia are also connected with copper. It's a sharing of bonds and it's the also extra charge or it's the oxidations number. Sorry, the oxidations number are also write down on the bracket over it's a charge pair. It's noted down that so plus 2. So classifications of complex compounds. So by the charge on complex ion, this is a cationic and anionic and neutrals. Cationic, anionic, neutral or cationic and anionic, both. Next one is compositions of ionization pair. Compositions by acids, base, salt or non-electrolyte. That one is example H2PtCl6 is the acids ionization pair and basis ionization pair AgNH32OH and salt is Na3Lf3. It's a salt and non-electrolytes. It's a PtNH3 twice and Cl2. By the nature of ligands, it's the nature of ligand we are separated that aqua complex, acido complexes, mixed ligand and amines. Aqua complex is ligand is water. It's a ligand H2O. It's a 6 and Fe. It's a charge sphere over the charge sphere. Outside the charge sphere is SO4. Showing that we are discussing that the also called this one is also called ionization sphere. This one is called you show this one is ionization sphere and show that, and this one is ionization sphere OHs and okay salt is Na3Alf3 F6 sorry. Okay, this one is the nature of ligand aqua complex. Sorry, we are discussing the nature of ligand and the first one is aqua complex, mixed complex, mixed ligands and acido complexes, amines. Okay, ligand is ammonium. The Zn NH3 for Cl2. So or mixed ligand is a COCl NH3 thrice H2O2 H2O bracket over 2 and NH3 twice. Ready. we are discussing in next video lectures, part 3, in to be continue the nomenclatures of coordinations compound in the next video lectures.